so that I have this recorded. Now I'm going to share my screen and we should see Blackboard and share. All right, so when you come into Blackboard, the laboratory materials for this week are in week 2 under laboratory materials. There are 2 sets of graphing data, and we're going to go through each one, and these are going to be the data sets that you're going to graph. I have 2 templates for the memos. One is a Microsoft Word version, and one is a Google Docs version. I don't care which way you do, whether you do it on Google Docs or you do it on Microsoft Word. I'm going to go ahead and download this because I'm going to have the Microsoft Word version coming through. So it's there. So it says this week's laboratory for all students. Everybody's doing it, whether you're on Zoom or you guys are here in the classroom, everybody is doing it. You're going to have the 2 Excel spreadsheets, and you're going to have 1 set of data on the Vernier data. And you're going to upload right here on Blackboard by 8 a.m. September the 3rd. So everybody gets them uploaded at the same time. I know that's going to be kind of different, but it's there. This data right here is the data that I'm going to use for demonstration purposes. So you can have it and you can see it and you know what I did with it there. And I will add this lecture because I think it's going to record much better than the previous one did. So in this lab, what you're actually doing is practicing learning the tools that we're going to use throughout the semester. You're going to be using the video analysis software, and I'm actually going to show you how to do that. You're going to be doing Excel graphs. Now you can also do it in Google Docs or Google Sheets as well as in Excel, but Excel is there. So let me also point out, and I think I pointed this out in class, if you didn't already know, if you go to the NOC webpage, maybe, get rid of that. And you come down here to information technology. You have in here, it has save on software and technology products. And if you click on that, it will take you to how you can get Microsoft 365. So if you didn't know that you could access that, you can access it there. And I think I pointed that out in class, but I want to make sure that everybody knows that you do have access to the Microsoft products. Or you can use Google Docs, Google Spreadsheets, whatever. Okay, that works for me as well. So let's talk about the laboratory memo template. So in order to access this, just click on the laboratory template and it will take you to the Google Docs page, or you can use the Word version, whichever way you want. They're the same. In your Google Docs here, make sure you put your name on it because I am likely to print out the laboratory reports. And even though your laboratory report is tied to you in Blackboard, if I have a stack of laboratory reports that I'm grading on paper, I won't necessarily know who's who. And with a bunch of you, it's hard to kind of track down whose report it is I'm grading. So make sure that you put your name in. For this lab, you can do it as graphing examples. You can do it as whatever. Just give this lab a title. I don't care what you title it. This lab is learning the tools. As we get further on in the semester, you'll know it's a collision lab, or you'll know it's a work lab, or you'll know it's something else. So you can put in there anything that you really want to have that part of it there. Then I want your submittal date. Now, while the labs are due a week from tomorrow for you guys, I wouldn't wait until next Thursday to be writing up your lab. Today's is not going to be quite so bad because everybody's going to have the video of how we went through and what exactly you're supposed to do. And so you can go back and go, okay, yeah, it's just going to cost you time to go watch the video again. But as you get further away, when you're doing the actual physical labs that we're going to be doing, it's going to be hard for you to remember, well, exactly what did we do? And if I've written 27.9 on my piece of paper, what does that 27.9 really mean? What was that I have on my piece of paper? So you want to make sure that you kind of do these as early as you can. So you'll put in whatever day you upload it, into Blackboard. In the laboratory description, in this section, I want you to describe what's being investigated. So like for today, you're learning how to graph in Excel, you're learning how to interpret some data, you're learning how to utilize the video analysis software. So those are the things that you're actually doing. So you want to make sure that you put that in there. As we move through the semester, while everybody's going to be doing their own today, as we move through the semester, you'll want to include who your lab partners were as we work through. And this is where you would put it, all right? And you want to include the date you collected the data, that kind of thing. In the equipment and materials used section, I would like you to include whatever materials that you use. So like today, it's going to be a computer, Excel spreadsheets, the Vernier analysis software. That's what you're utilizing as the equipment. As we go through labs later on, you may say we used a bathroom scale. You may say we used a motion detector. Whatever it is that you utilize to perform the laboratory, it's going to go in that section. And it can be a list of materials. The materials used in this lab were semicolon, that's fine for that part. In this section for the experiment, you're going to detail how the experiment was done. This one's going to be kind of easy, right? We're going to utilize the tools in Excel to create the graph. This one's going to be kind of easy. Is we move through and know there was not a laboratory book that you purchased from the bookstore, because I'm in the process of rewriting all of the labs so that we can have these all work. If there is a laboratory that I'm going to hand out, for example, when we use the Vernier systems, I'll probably hand you the Vernier laboratory that we used. Or for the folks that are on Zoom, there's an IO lab version of a similar laboratory. If you are using that, I don't care to see those steps rewritten in the lab report. You can say, we utilize the Vernier lab report and we performed steps 10 through 12, or we performed steps 10 through 16. But we made a modification in step 12 because we didn't have something that was that long, or we didn't have that particular mass. You can utilize that, so you're not having to retype that individual lab report, but you will have to reference that lab report or that lab outline. Basically, what you are doing in this section is you're trying to provide as much information so that, let's say somebody had to come in and do the lab later, that they could actually recreate it and do what you did. Because that's part of the scientific process, is when we publish a paper, somebody else is going to go out and try to recreate the experiment that was performed. And that's what you're kind of doing in this part. Then here, it's the nice version of the data, the clean, pretty version of the data. So when we collect data, the Vernier systems and the IO lab systems may have a data table that you're collecting data in that data table. And that's where you're handwriting in, I measured this, and this was 27 centimeters or whatever you've got. And you've got that handwritten part. In the laboratory memo template, you want to have a nice table here, but you're going to include your handwritten stuff as an appendix to the report. So you're going to have that as an appendix, but this is where it's going to be nice and pretty and neat. Then you've got down here is your data analysis. So for today's lab, you're going to show me your graphs. You're going to cut and paste your graphs into your report, and you're going to say, this graph, there was a correlation, and that correlation looked like a straight line. And here are my values for the slope and the y-intercepts. So you're going to put your data analysis in there. It may contain graphs, it may contain equations, it may contain calculations, which is one of the reasons why I wanted to have the Word version downloaded, because I'll show you where you can actually do some of that. You can do the same thing in Google Docs, but I don't use Google Docs quite as often. So I'm going to go over here and it will say, we can always do how to enter an equation into a Google document. So how to write an equation in Google Documents, because it's always going to go in here. And it'll tell you exactly step by step. A lot of times you'll have a nice video. Don't be afraid to Google that and have it come up. Because one of the things that happens, even I have to go back and Google it because I may not have entered that equation in a while, especially if I'm working in a spreadsheet. I haven't used that function in a while. So I'm always going back and typing how to do that. And it gives you all of the information on how to do it. So you can utilize that part as well. So that's something, don't hesitate to do that part. Then I want a conclusion, all right? I want a conclusion. In this lab today, one of the graphs one of the charts has got 4 sets of data. And you're going to determine the acceleration due to gravity from those 4 sets of data. And you're going to make a conclusion based on the data that's in the spreadsheet as to what planet or moon you happen to be sitting on based on the given data. So when you do that, you're going to also want to do an error analysis, and you're going to want to compare the result that you determined from your graph to the known value. So you want to make sure that you've got that so that you can actually do that. Then you've got your references and any appendices that are there. So does that make sense about what I'm expecting in the laboratory report? And I'm not expecting these to be horrendously long. This one's going to be several pages just because you're cutting and pasting graphs in it. But the actual text that you're going to write is not necessarily all that long. Some of them will be longer than others. Some of them will be very short. I know there's one elevator lab that's going to be really, really short. So I'm not expecting, 20 pages out there, just enough to make sure, did you get what you were out? And if there are any questions that I'm going to have you answer, you're going to want to discuss those questions in the conclusion. For example, if we were doing a simple pendulum lab, one of the questions is what's going to happen if I make the length of the pendulum longer? Is the period going to speed up or is the period going to slow down? And you're going to have to answer that kind of a question in the conclusions. So makes sense? Guys, I got nods, everybody. I've got smiles, I got nods, that's good. All right, so let me open up. I'm going to come down here and I'm going to open up the Word document to kind of show you a couple of things. Okay, yeah. So I want downloads and I want the Word document and it'll open up here. Okay, that's weird. Okay, now it's seeming to be okay. All right, so Madeline, do you see the Excel document or not the Excel document, but the Word document?
Yes, ma'am.
All right, cool. So you see it's the same, but up here, a couple of things when you're doing stuff on, at least in Microsoft Word, if I click the insert over here, and I'll move this out of the way, over here is where you've got your equation builder. And over here is where you have your mathematical symbols. So it's in the insert page and your equation and symbols. So I'm going to go in here just to play for a second, and I'm going to enter a table. So I'm going to enter a table. If you've never entered a table, you can enter. This is another nice way to enter your table, and this could be run number, and this could be position. I didn't spell position right. So this can be position. And this one can be velocity. And this one could be acceleration. And when you do a table, you want to put your units in there. So that's position in meters. Velocity is going to be in meters per second. And acceleration, if I can spell correctly, will be in meters per second squared. And if you've never done a superscript in Word, you highlight it. And of course, it comes up with some things right there, but I'm going to go ahead and show you where it is on the home screen. Here's where you can do a subscript, and here's where you can do a superscript. So I can just do a superscript. And so my units are in the header. So when I come down here, this is going to be run number 1, and I'm just going to put in 25.6 just for grins and giggles, 13.5, and 26.8. And I don't have to put the units with the number next to it in the table because it's attached in the header. And if you wanted to center this data, you can just highlight your row and use the centering tool, and all your numbers will move to the center. So that's how you can insert a table into your document so that you can play with it and create nice tables and reproduce tables for your data in your Microsoft Word document. So, and then you can also do, when you do the insert, if I wanted to write an equation, so just for grins and giggles, I'm going to write an equation in here. And it says type my equation, and now I have a bunch of equation tools. So I'm going to say that x is equal to the slope times time plus the y-intercept. But I can also come in here and add fractions and insert fractions. This is where you will insert fractions. I can do scripts, things to the power. I can put brackets. I can put a lot of different things in there. And when I'm done and I look at my nice little table here, I have a nice little equation that's been put into my document. So it just takes a little bit of practice to put in equations and tables, but I wanted to show you where you would go on your ribbons up in, that's what these are, these lovely, the fancy Microsoft term is, these are ribbons. And if they don't show up, say your screen looks like this, when you click on one, it'll be there, and there's a little tack, like a thumbtack, and you can tack it so that it'll keep the ribbon going. So a couple of little tips for using Microsoft Word, and Excel is going to be very similar. It's just that you're doing something a little different. One's a word processor, and one is going to do those calculations and graphs. And feel free to holler at me, say, hey, I need to know how to do this. Or like I said, go ahead and ask good old Google a question. All right, still making sense. Okay, so I'm going to open up all 3 of these spreadsheets here. Get them coming and going. There we go. All right, Madeline, can you see the spreadsheets?
No, it's changing. 1 second. It's just a black screen.
Just the black screen?
Yes, ma'am.
Okay, let's see. Let me stop share, and then I'll share again. Okay. All right, I'm going to share this one. We'll start here. No, we'll start here. So I'm sharing that. So now you should be able to see one.
Yes.
Okay, great. Thank you for being there, because that makes it easier for me to see that they're actually seeing something instead of the other. So this is the sheet that is going to look at, you're answering the question, do I have a correlation? I've got 3 sets of data, and this is force and mass, this is force and velocity, and this is force and position. What you're going to do with this one is you're going to graph each set of data, and you're going to look at that data to determine whether or not there is a correlation between force and mass, or between force and velocity, or between force and position. And you're going to have to justify whether or not you think there's a correlation based on how your graph looks. And when we plot a graph, you'll get to see that a little bit. Then down here, we've got two sets of data. And what you're going to do is plot this data, and then you're going to describe in words what you think the object that's moving is doing. And we're going to work through one of those so that you can actually see that. But these two are, you're going to have two graphs where you're going to describe the motion. These are three graphs where you're going to tell me whether or not there's a correlation. So that's one set of data. And when I open it up, I'm going to share my screen again. Now I'm going to come over here for this data set for posting. We'll share. And you will have to click the enable editing when you open these up so that it edits. So you see the spreadsheet, Madeline? It says data set 1, 2, 3, and 4.
Yes.
All right. Here are the known accelerations due to gravity for the objects that we're talking about. These are the known accelerations due to gravity. You have 4 data sets, and you're going to plot these data sets, and using the equation that you get on your graph, you'll be able to tell me which one of these you're on. There's Titan, which is a moon around Saturn. These two are extra solar system planets. They're around, this one's around another star. This one's around another star. So you're going to tell me which one of these space objects that data represents. And when you do that, you're also going to give me a % error calculation based on your data that you got. All right. So I'm going to switch I'm going to stop sharing. I'm going to switch to something else real quick. And, okay, hang on. Okay, I want to share. And I want to share, let's see, I'm going to have that one up. All right, now I'm going to minimize so I can actually get there. Now I can do this. Share my screen. There we go. I'm going to share this. Okay, so let's talk about some things first so that you guys have the data for it. So Madeline, you should be seeing a document camera with some lined paper.
Yes.
All right. So when I plot a graph, right, whatever my graph is, and what we did in good old algebra class was this is Y and this is X. And I've got some data points that are out here, and I've just got some random data points. And I'm going to draw a line through that data, and I'm going to draw what we call a best fit line. All right, I've got a best fit line in here. Now, we know from good old algebra class that what we've said here is Y is equal to mx plus b, right? I've got Y is equal to mx plus b, where m is the slope and b is the y-intercept. Let's see if I can spell correctly. So I got Y is the one object and B is the y-intercept. Now, if I take this and I say this is going to be position and this is going to be time, I can now write this as, and we're going to go ahead and use D to be position just for grins and giggles. I'm going to say that D is going to equal whatever slope times time plus my initial position, and that 0, and I could also write it as DI. This means initial position. So I can now rewrite my equation here as my position is going to equal some slope times time plus my initial position. Yeah. Sure. Let's see. That one. Let's see. Do I have light switch on that side? We'll find out. That better?
Yeah. Thank you.
All right. I probably need to turn the light on here. That better? There you go. You have to give everything a chance to adjust.
Yeah.
Chance to adjust. So I've got a y-intercept. So now, if that's the case, well, let's look at the slope. And we all remember that slope is equal to rise over run, right? Or in this case, it's going to be a change in position or change in D with respect to time. So I can go over here and I can get this, right? I can draw my little triangle and I can get it, but let's look at the units here. This means the units are in meters per second. If I have this in meters and I have my time in seconds. So we're going to find out tomorrow that a change in position with respect to time is something called velocity. So now I can go over here and I can rewrite my equation. Now my distance is going to equal velocity times time plus my initial position. And now I have an equation that has meaning. This plot now has meaning. I can actually go in there and get this plot has meaning. So we're going to find tomorrow that we're going to say X, because that's how we're going to represent position. X is going to equal velocity times time plus whatever my initial position is. And we're going to see that in a kinematics equation on Friday. We're going to see that in lecture. All right. So I can do that. This also tells me, because it's a straight line, that I'm at a constant velocity, because it is a straight line. I'm at a constant velocity. So that gives me something that's making a little bit more sense. We've got that constant velocity. We've got that piece in there. Now I can take this graph and it actually has physical meaning. Well, one of the graphs, especially when I'm going to do those planetary graphs, I'm going to plot something different. I'm going to either plot a position versus time graph. And in that case, what's going to happen is I might have a graph that looks like this. It's got a curve to it. And if I go in and do a curve fit, and I'll show you how we're going to do a curve fit, but I go in and I get a curve fit, this is going to represent something like, if I were to doing this in my algebra class, it's going to represent y is equal to some constant times time squared plus some constant times time plus some other constant. Now, if I'm doing this as a position versus time graph, I'm going to have that information. And it turns out what we're going to see is that X is going to be acceleration. And I'm going to go ahead and write the words out. That way we don't get it confused with just our acceleration times time squared plus my initial velocity times time plus my initial position. And if I'm doing my unit analysis, this is in meters per second squared, and it's times seconds squared. This is in meters per second times seconds. And this is in meters. And this means the second squares will cancel, and I'm in meters. The seconds will cancel. I'm in meters, and this is in meters, so everything is going to be able to be added together, and it's going to be really nice. But if I go in here and I do my curve fit, whatever is in that spot, and actually what we're going to see for when we actually derive that, this is going to be 1/2 the acceleration. When we derive it, when we put physical meaning to it, it's going to actually have a 1/2 in front of it here. And we'll see that tomorrow in lecture. But this means I can take that, and if that's 1/2, whatever this value is, that's 1/2 my acceleration due to gravity is equal to A. My gravity is going to be 2A. I can read the acceleration due to gravity right off of my graph. I can read it right off of my graph. Similarly, you are going to see a plot that looks like this. This is a velocity versus time graph. And in this case, if I take that same data, I'm going to get a nice straight line, which is going to tell me I have a constant value for that. And the equation we're going to show tomorrow is that velocity is going to equal my initial velocity plus my acceleration times time. And if I'm doing planetary data, that right there is my acceleration due to gravity. And I can read it right off of the graph. So by plotting your data, you're going to get, number one, you get a little bit of averaging, because like in this one, this graph, I'll move it over here because I know some of you are still writing, but I have a lot of data that's kind of scattered, and I drew what we call a best fit line. I'm kind of averaging out the error of the measurements, kind of averaging it out, getting rid of that error a little bit by doing a best fit line in order to get that data. And now I'm going to be able to come up with a physical value for gravity. And a lot of this will make a little bit more sense tomorrow when we actually cover that in the theory. But because of this, I can take data and actually have it make sense, make physical sense. So I'm going to stop sharing. And then I'm going to come back, open up my other graphs for demonstration. So I've got it up there so I know which one it is. And now I'm going to share my screen again. Okay, that's entertaining. What happened to it? And that's for graphing. This one right there, that's the one I want. I'm going to do this, lower that one, come over here to share, close that, try it again. I might be sure I won't show all windows. There it is. I got it. So do you see my Excel spreadsheet, Madeline?
Yes.
All right. So this was from the first set, the first chart where you're actually going to plot, and this is the one that we're going to plot a graph that we're going to describe the motion that we see in the graph. So that's what we're going to do. We're going to describe the motion that we see in the graph. So first thing you do when you get into your Excel spreadsheet, make sure that you've gotten so that you can do editing. I'm going to highlight the data. So I'm going to come in and I'm going to highlight the data that I want to graph. Over here on the ribbon, we're going to click the insert. And right here is where all of our graphing tools are. Right there's where all of our graphing tools are. So we're going to hit this is a scatter chart. So we're going to hit our scatter chart. And I'm going to hit that one right there. And now I've got a graph of that data. I have the position is right here on this axis. And you can come over and you can format your axis. I'm going to move this out of the way so we can actually see it. You can format your axis how, where you want it. We can also do our text options. You can play with it and get everything that you want to with it. That's why I would encourage you to go, how do I do that in Excel? Learn how you want to put your titles in and put your units in, because that's one of the nice things that you've got in here. Like for my chart title, I can go in and say motion of a cart and do position versus time. So now I have a title there. And so now I can go in here and I can look at it. And what we want to do is now describe the motion of the cart. So in this case, we're going to start behind the starting line. So I'm not starting at precisely 0. And when the clock starts, I'm going to travel what looks to be at a constant velocity because I've got a nice straight line through this data. I got a totally nice straight line through this data. Now, next week, when we come in, we're going to play with a motion detector and we're going to look at graphs and you're going to try to recreate the motion on the graph. For those that are working with the IO lab, I'm going to have you try to recreate the motion on a graph and be able to do it using the little IO device. So we will be able to do looking at actually trying to mimic the motion of the graph. So it looks like I've got a pretty straight line, constant velocity. Then all of a sudden at 6 seconds, if I'm dealing with a cart or if I'm dealing with a model, I've got to wait for something. I'm going to sit there at that particular position and I'm going to sit there for about 4 seconds. I'm not going anywhere. If I'm in a car, I'm sitting at the stop sign, or out here in Enid, I'm sitting at the railroad track as the train's going by. I am just going to sit there. Well, after 9 seconds, it looks like I can start off again, and I'm going to start off at a constant velocity until I get to 14 seconds, and then I'm going to stop. I'm going to sit there at 14 seconds, and then I'm going, oops, maybe what happened to me, I left my phone on top of the car and I realized that, and I better stop and go pick up my phone before somebody runs over it, right? So now I'm going to go backwards at a constant velocity, because what we learned about vectors is vectors have direction and magnitude. So this is telling me I'm going in the reverse direction. Then I'm going to sit there and stop, and then it looks like maybe I've accelerated or decelerated, as the case may be, and then maybe I've accelerated through here. So you're going to plot, you have 2 sets of data and you're going to plot that data. And then I want you to interpret the motion being described by that graph or those 2 graphs. So that's the purpose of this one. And again, because we are going to actually do that, and then I'm going to go ahead and get rid of this graph. And you'll copy that graph and put that one in your report. So now I'm going to do a position versus time graph. Move my people over here. I'm going to do a position versus time graph. So I'm going to highlight that data. I'm going to do insert. I'm going to go ahead and do my chart there. I'm going to do position versus time graph. And voila, I have got something that looks like a curve. And because we're dealing with gravity and we're dealing with everything else, that particular curve, I have a pretty good idea that that is going to be a polynomial curve and it's going to be a quadratic. Now, how do I put the best fit on this chart? Well, what I'm going to do is I'm going to click on the buttons. So I've highlighted the buttons. I've highlighted my data points. And then I'm going to right click with my mouse, and down here it says add trend line. So I'm going to click on that add trend line. Now it's highlighted that when I did that add trend line here, it highlighted that it was linear. That's the default that this one particularly went to. And we know that that's not a very good line. It's an ookie line. And we're going, well, no, we're pretty sure that that's going to be a polynomial. and it's probably going to be to the order of 2. And now look at my data. My points fall very nicely on that particular line. Now down here, you can display the equation on the chart. So that's what I'm going to do. I'm going to display the equation on the chart, and voila, I have the equation on the chart. The other thing I might want to do when I'm coming over here and I'm displaying this, so I'm going to come back here, is I may want to display the R squared value, because that's going to tell me how well of a fit it is. And in this case, it's 1. Every one of those points fits on the data, and it looks really, really nice, and I'm able to do it, and I've got a very nice correlation. Now, if this is position versus time data, we know that that's going to be 1/2 the acceleration due to gravity. So in this case, this chart says whatever planet we're sitting on, the acceleration that I'm looking at is 1/2, or it's 1/2, or that's 1/2 of it. So gravity is going to be like 1.7 or 1.2. Sorry, 2 times 1.6 is going to be 1.2, or 2 times 0.6 is going to be 1.2. So I can read that information right off the chart. Now, I also want to do a position versus velocity graph. So what I'm going to have to do there is I'm going to have to recreate my data. So I'm going to do a copy, and I can do copy a couple of different ways, right? I can come over here and I can say copy, and I'm going to paste it right here, and I can come in and paste the values. I'm going to copy my velocity data, copy and paste my values. So I've got the data there. Now I'm going to go ahead and I'm going to plot this chart, and I'm going to insert my chart, do my scatter plot. And in this case, you can see I got a little bit of variability in my data. So I'm still going to do the exact same thing. I'm going to highlight my point. I'm going to do a right click on my mouse, and I am going to say add a trend line. And this time I want it linear, and I'm going to have the equation displayed on the chart, and I'm going to have the R squared value displayed on the chart. And now I know that I'm traveling a velocity versus time graph is going to, if I've got a straight line, gives me a constant acceleration. And now I show that it's 1.3, which is kind of what I would have expected based on the data that we had right up there. 2 times that, it's going to be closer to 1.3 than 1.2. I still have a very good fit on my data. So that works out really nicely. I still have that really nice fit, and I can do that. Make sense? Okay, so I'm gonna go ahead and close this one out. I'm not gonna save. Yep, because the shared window is closed. All right, now I'm gonna go back to Blackboard here. Maybe. Okay, I'm going to clean up my windows just a little bit and go ahead and close this. Close that window. And I'm going to come back over here, and I'm going to go back to Blackboard. There we go. Come back to Zoom, do a share screen. There we go. All right. So the next part of the lab that you're going to do is you're going to work with the Vernier video analysis software. So over here on this side, there's a link that takes you to the Vernier video analysis software. You're going to click that link, and it's going to come in, and it's going to take you straight to this particular window where you can import your own video, but the video we're going to work with is the basketball shoot video. So we're going to click on that, and it'll pop up into the video analysis screen. So a couple of things that we can do systems, we can play with my origin, but we're going to sit there And what we want to do is we want to start tracking the basketball when it leaves the guy's hands. And you can move this over, frame by frame. You can watch him go up, but once it leaves his hand is when we are going to start tracking. So I'm going to use my tracker tool that comes up. I'm going to go to the center of my basketball and I'm going to create a mark. And I'm going to do this as each frame progresses on my basketball. And over here, you're starting to see that starting to see data getting collected in both a spreadsheet and in a graph. So I've got this coming and not 100% perfect, but I've got it coming. It's going to reach the top. And we're about at the top, I think. Yep. Now we're starting to come back down. And that kind of gives me enough of the information that I need. So I'm going to move this out of the way. So over here, I've got my data and I can actually apply a curve fit to the data. And I've got the red data, looks pretty much like a line, right? I got my curve fit and there's my line. I can also do a quadratic and now I've got my curve fit for my quadratic. And I can say apply and it's got the information for my quadratic and I can look at it for my straight line. But you can see the red indicates the position along the x-axis and the blue indicates the position along the y-axis. And one of the things that we were mentioning yesterday about our coordinate systems is that they're going to be independent. The motion in those coordinate systems are independent of each other. So the y position is definitely changing with respect to time and the x position is definitely changing with respect to time. And you can play with this and look at it. And I think, if I remember right, I can print my screen. You can do a print screen and you should be able to download. The user manual is in there. You can access the user manual as well. But you can be able to get your data that you got for this situation. So a reason I wanted you to do that is I wanted you to look at how you can use the software and play with the software. It's pretty intuitive. And then to look at the fact that when on a bouncing ball like that, I have independent motion in the y direction and independent motion in the x direction. This is traveling at a constant velocity and there's no acceleration. The y direction, there's acceleration, and we happen to know that that's the acceleration due to gravity. So we can get that information. And if I come over here and I do that plot and I look at my quadratic and I apply the curve fit and I do that quadratic on that one and I apply it, I've got a value of negative 37.2. We don't know what these units are. We don't know what those units are because we're just arbitrarily, and this is in terms of pixels. So I don't know what those units are to get in there. I can create it, which is kind of fun on this video analysis software. If I know the measurements, I can actually put it in and I can actually make it real. But that would be equivalent to the acceleration due to gravity. So you can actually look at it and you can also track your seconds down here at the bottom. And we'll do some cool things, take a video and play with a video and see how did that work, and we can actually plot things. I've got a couple of videos that we'll play with tomorrow in the video analysis software, so you'll see it play a little bit differently as well. So that's the other thing that you need to do with respect to the lab, and your software is right there in Blackboard. So now I'm going to stop sharing. I'm going to go back. Oops, I should have kept sharing. Sorry, my bad. We'll go back to share. Maybe. Okay, I want to go back here because I wanted to do something in Blackboard. I want to go back to my courses. So I'm going to leave, come back to our class. Got that. Go down here to course material and assignments. Week 2, laboratory materials. So what you're going to do, just to review, there are 2 spreadsheets. These 2 right here. The data set 1 is for determining gravity on the planetary bodies. You're going to plot those 4 graphs and you're going to determine gravity on the planetary body. Percent error, remember from chemistry, most of you had to do percent error. It's the absolute value of the measured minus the real divided by the real times 100%. That'll get you the percent error. So you're going to compare when you plot your graph, you're going to go to that table and you're going to say, I think this is Titan based on the slope of the graph that I got, or based on the quadratic equation that I got. And if that's correct, that experimental data would be off by plus or minus X% based on that percent error. You've got this Excel spreadsheet, the data, general data for graphing. You've got that Excel spreadsheet that you can go in, and you've got 2 data sets that you're going to just plot and describe in words the motion that occurred. And then you have 3 data sets that you're going to use that data to determine if there's any kind of correlation between force and mass, force and velocity, or force and whatever, I think it was position, and justify that answer. Then you're going to do the Vernier video analysis of the basketball shoot. That basketball shoot video, that's the one you're going to work with. Everybody's working with the same one. And that one will go in, and then you're going to put it in the laboratory memorandum and submit it by class time a week from tomorrow. Make sense? Okay. So Madeline, that makes sense?
Yes.
All right. So what I'm going to also do is I'm going to stop recording here in a minute, and I will let this do its little thing, and I will upload this video, which should be better than the video that I uploaded on Monday. For those of you that are here in the classroom, I am here to let you play with some graphs so that you could ask questions and go, okay, I got it, or I don't have it. And but once you feel like you're comfortable enough and you feel like you're okay, you guys can bug out. Okay. All right, Madeline, you got any questions?
No, ma'am.
Thank you for being here, because that makes sure that I've got the recording right. I greatly appreciate that. All right, I'm gonna stop.